And you are live, Lisa.
Good morning, and good afternoon and good evening. As the world goes to Mars, we're in all the time zones around the globe. I'm Lisa May, Chief Technologist for Lockheed Martin's Commercial Civil Space Advanced Programs and former chair of the International Mars Exploration Working Group. I am thrilled to moderate this panel on the ever-increasing number of Mars-faring nations and agencies and their upcoming Mars plans. Today's panelists are Dr. Lori Glaze of NASA, Mr. Adnan Rais of the Mohammed bin Rashid Space Center, Ms. Kelly Geelen of the European Space Agency, and Dr. Masaki Fujimoto of the Institute of Space and Astronautical Science in Japan. Dr. Glaze is the director of NASA's Science Mission Directorate's Planetary Science Division. Before coming to NASA, Dr. Glaze served as the chief of Planetary Geology, Geophysics, and Geochemistry Laboratory at Goddard Space Flight Center in Greenbelt, Maryland, and as the Deputy Director of Goddard's Solar System Exploration Division. Her research interests include physical processes and terrestrial and planetary volcanology, atmospheric transport and diffusion processes, and geologic mass movements. Dr. Glaze was a member of the Inner Planets panel during the 2013 Planetary Science Decadal Survey and had a role on the executive committee of NASA's Venus Exploration Analysis Group, more fondly known as VEXAG, for several years, serving as the group's chair from 2013 to 2017. She was a member of the Planetary Science Subcommittee from 2011 to 2013. And as Director of Planetary Science, her portfolio includes NASA's Mars missions. She will speak today about Mars 2020 mission with the Perseverance Rover and Ingenuity Mars Helicopter, Mars sample return, and the feed forward to sending humans to Mars. Mr. Adnan Rais is the Senior Director of the Remote Sensing Department at Mohammed bin Rashid Space Center. Adnan and his team have been responsible for development of the ground segment for the Emirates Mars mission and future deep space missions led by the UAE. He's also responsible for commercialization of the Mohammed bin Rashid Space Center projects, including imaging products and services. He was part of the team that built the UAE's first ground station and the ground segment of the Dubai satellite series. He introduced commercial ground support and antenna hosting services from the EIST ground station in Dubai. And today he will be speaking to us not only about the HOPE mission, but also about the UAE's plans for sending humans to Mars next century. Ms. Kelly Geelen is currently the Systems Engineering Team Lead for the European Space Agency's Earth Return Orbiter, spacecraft that will return Mars samples back from Earth as part of the collaboration between NASA and ESA for Mars sample return. After seeing Mars Pathfinder as a teenager, she pursued a career in Mars exploration. She studied aerospace at Delft University and started her career as a systems engineer for future missions for Airbus in Stevenage, UK. She moved back to ESA and ESTEC to work as a systems engineer on the newly started Mars Robotic Exploration Program at ESA, and working on the Mars sample return architecture and potential precursor missions. From this, she moved on to Bepi Colombo, and after the launch and commissioning of Bepi Colombo, a mission to explore Mercury, she returned to Mars. Today, she will give us an update on the status of the ExoMars rover, planned to be launched in 2022, and discuss the Earth Return Orbiter and its role in the overall Mars sample return campaign. Dr. Masaki Fujimoto joined JAXA in 2006 and became the director of the Department of Solar System Sciences at the Institute of Space and Astronautical Science in 2009. He has been the Deputy Director General of the Institute since 2018. Last year, he chaired a committee for the International Announcement of Opportunity for Hayabusa Sample Analysis and has supported JAXA's small body sample return missions since then. He is proud to be one of the founding members of the MMX mission. And with that, I would like to turn it over to Dr. Lori Glaze. Take it away, Lori.
Thank you so much, Lisa, and hopefully we can get my slides up here quickly. I'm very, very happy to be here to talk with you today about the Mars activities, a few of the Mars activities that we have going on within NASA. I, of course, am missing the opportunity to interact and interface with folks face-to-face this year, but hoping that at some point in the future we'll all be able to gather in one place again. You can go on to the next slide, please. As Lisa says, I'm going to speak a little bit about Mars 2020 and Mars sample return and feeding forward, but all of this work is done in the context of a much broader Mars program, not just within NASA, but the global community. And this chart shows the current fleet of operational missions that are operating at Mars, as well as those that are planned to happen in the future, not just from NASA, but from the whole global community. And Mars is really becoming an incredible gathering spot, an incredible focus of science and exploration. And this whole global effort to trying to better understand Mars has really followed a very deliberate path of stepwise exploration, beginning in the earliest phases where we were trying to follow the water, try and understand the story of water on the surface of Mars and what that might mean for habitability. So beyond finding that there was and determining there was water present on the surface of Mars, then trying to understand those environments and whether or not they could have been habitable at some point in the past and perhaps have been places where life could be sustained. And now as we move forward, we are really in a great position to really start actually looking for those signs of life. And the current missions that are on their way are starting to get at some of those questions. You'll hear a little bit about that. And we're, of course, all of this looking forward to the future and trying to find a way to eventually send humans to Mars. And a lot of the work that we've been doing to date and that we've got planned in the future is helping to feed forward towards that future goal of sending humans to Mars. So if you can go to the next slide, please. This is my Glamour Shot. This was an exciting activity, just happened on July 30th. For NASA with the launch of Mars 2020, which included the Perseverance rover and the Ingenuity helicopter on their way to Mars. Of course, the Mars 2020 mission, Perseverance, is a mission to land in Jezero crater on the surface of Mars. The first ever really astrobiology-focused mission. It will do lots of geology on the surface of Mars, characterizing the crater and the geology that's present on Mars. But the specific landing site was chosen because of its unique feature, which is a river delta, which is evidence that water had flowed into a standing body of water, leaving a deposit of sediments. This deposit, we know, is several billion years old, about 3.5 billion years old. And if life had started to form at that time, 3.5 billion years ago, we would expect it to be preserved in a deposit such as this river delta that's present in Jezero crater. So one of the main focuses of this mission, of course, is to understand the habitability of that environment and whether or not there's biosignatures that potentially ancient life may have been preserved in that deposit. But the other thing about Mars 2020, of course, its other main goal is that it is the very first step in Mars sample return. In addition to doing the science in situ on the surface, Mars 2020 will also identify key locations of rocks and soils to collect samples, to drill and cache those samples in tubes and leave them in depots on the surface of Mars for eventual return. And if you can go on to the next slide, this is our next big campaign, is Mars sample return, which will be the first ever round trip to Mars, or first ever round trip to any other planet, including 3 launches, 2 from Earth and 1 from Mars, in order to bring those very precious samples of the rocks and soils in Jezero crater that are collected by Perseverance, to bring those samples back to Earth. You're going to hear more about this from Kelly as well, but this is a partnership mission done in collaboration between NASA and ESA. As I said, involves 2 launches from Earth, the first being a NASA launch of the sample return lander. That sample return lander actually also carries a payload, which is provided by ESA, which is a fetch rover. And then the second launch from Earth is the ESA launch of the Earth Return Orbiter. And that Earth Return Orbiter carries a NASA payload, which is the capture and containment system that will actually bring those samples back to Earth. As part of this process, the sample return lander will land on the surface. The fetch rover can go out and collect those samples that have been left on the surface. Mars 2020 Perseverance, if it's still operational, can also bring samples back to that return lander, deposit them into a capsule to carry the samples, but get loaded into the Mars Ascent Vehicle. That third launch, which is the launch from Mars, will launch those samples into orbit around Mars, captured by the ESA Earth Return Orbiter, and brought back to Earth. An incredibly ambitious program, but we're working together with ESA on a schedule that would see launch of this campaign in 2026 and eventual return of those samples in 2031. But I'd like to go back to Mars 2020 and think forward, because not just Mars 2020 isn't just feeding forward to Mars sample return, we're also laying the groundwork and taking steps to help prepare us for human exploration. So if you can go on to the last slide, please. I'd like to talk for just a few minutes about some of the experiments on the Perseverance rover that are directly helping us prepare for future human exploration. One of the most obvious is the MOXIE instrument, which is carried as part of the payload, an experiment that will convert the carbon dioxide in the atmosphere to breathable oxygen. We're also carrying calibration targets for the Sherlock instrument, which includes some spacesuit material as well as some helmet materials. And we'll be able to watch how those materials respond in the Mars atmospheric environment over time as we continue to laze at those calibration targets with the Sherlock instrument while it's operational on the surface of Mars. We're also carrying the META experiment, which is going to be monitoring the weather on the surface of Mars, temperatures, pressures, dust, other environmental conditions, again, to help us get better characterization of what that environment is like if we're going to send humans to Mars. We're sending the RIMFAX instrument, which is a science instrument to look for subsurface water and ice, which is not only relevant to science questions about the environment today, but also important to future resources that might be important to sustain human exploration on the surface of Mars. We're also demonstrating some really important key technologies that will feed forward to future human exploration. The first being the implementation of a new technology called terrain relative navigation, which is an autonomous hazard avoidance system that will be implemented during the landing sequence, which, as I'm sure most are aware, is a very rapid autonomous activity. It takes about 7 minutes to go from the top of the atmosphere to the ground. And the terrain relative navigation allows us to autonomously detect hazards and to adjust the position of the landing to allow us to actually have access to landing sites which might have more hazards than would previously have been allowable. So this allows us to actually access places in Jezero Crater that, for example, the Curiosity rover would not have been able to access, would not have been able to land there. In addition to that terrain relative navigation, which will be certainly necessary for future human exploration to do precision landing, we also are testing the Ingenuity Helicopter. This will be the first ever powered flight on another planet. This is an incredibly challenging thing to do, to fly on Mars with the low density atmosphere. This is an experiment. It's not actually required for the success of the mission, but we're extremely excited to demonstrate this technical capability on the surface of Mars, as it will feed forward in many different ways to human exploration, where we will, in addition to having human presence on the surface, no doubt require also additional robotic assistance and working with robots and humans together in human exploration. And so with that, I think I will pass it back to Lisa, and I'll be looking forward to taking questions. Thank you.
Thank you, Lori. I appreciate that talk. And next up is Adnan Rais from the Mohammed bin Rashid Space Center. Take it away, Adnan.
Thank you very much, Lisa, first of all, for the opportunity to be back here at the Human to Mars Summit virtually. I had the honor to participate a couple of years ago in Washington, D.C. Today, my talk, I would like to cover two main topics. Basically, the first one is the Immerse Mars mission, the HOPE probe. And secondly, I would like to give you an overview about our Mars 2117 strategy. As you know, the Immerse Mars mission, the HOPE probe, which was launched on July 20th, and it's currently on its way to Mars and should reach Mars by February next year. It's a collaborative work between the Mohammed Space Center, U.S. Space Agency, and 3 main universities in the United States, working with the University of Colorado Boulder, Arizona State University, and UC Berkeley on the development of all aspects of this mission. The main scientific objective of the Immerse Mars mission is to study the Martian atmosphere and provide a global, seasonal, diurnal, day-to-night coverage of the Martian atmosphere. It's a pure scientific mission. We have clear science questions that were identified from day one, and those science questions were driven from the knowledge gaps given by MEPAC working group. We have 3 main science questions. How does the Martian lower atmosphere respond globally, diurnally, and seasonally to solar forcing? How does the Martian exosphere behave temporally and spatially? And how do the conditions throughout the Martian atmosphere affect the rates of atmospheric escapes? And those questions, basically, we have a solid scientific objectives and investigations leading to the development of the main instruments. In terms of investigations, we have 4 main investigations in our mission to sample the Martian lower atmosphere on sufficient spatial and temporal scales, to better understand the processes that are driving the global circulation and the current Martian climate on sufficient spatial and temporal scales, and also to measure the dynamics and energetics of the thermosphere, through which all escaping particles must travel. And the 4th investigation is to determine the 3D structure and temporal variability of hydrogen and oxygen. To summarize, basically, our mission will provide a global weather mapping. It will provide better understanding of the climate dynamics, linking the layers, and study the atmospherescape. On board this mission, we have 3 scientific instruments that will allow us to answer the science questions. The 3 scientific instruments are the Immerse Mars infrared spectrometer, the Immerse Mars ultraviolet spectrometers, and we have also the Immerse exploration imagers. So those are the 3 main instruments on board the mission. And in order to achieve the global seasonal diurnal coverage, we have a unique orbit, 20,000 kilometers by 43,000 kilometer orbit, which allowing around 55 hours of orbital period, which means that we have 3 orbits per week, allowing us to have a full coverage of the Martian disk. So we're very excited about our Catalyst project and deep space exploration. And we're looking forward to the Mars orbit insertion in February, and then starting the science orbit and starting collecting the data of the Martian atmosphere after the Martian orbit insertion. So this is the Immerse Mars mission. The second strategy that we have within the UAE National Space Program is the Mars 2117. It's a 100 years strategy, a generations strategy to build a settlement on Mars and sending human to Mars. This strategy, we have 4 main pillars. The first one is the research and development. And here where we develop all the technologies and science needed in order to allow future missions to Mars. And the second one, which is the education, which is very important for us to prepare always the next generation to be ready and contribute in our future space programs. The third pillar, which is the enablement, we have to enable our universities as well as the industry to contribute significantly in the development of space missions and space programs. And the 4th pillar, which is the international collaboration, which has been an integral part in all of our programs and all of our projects. Under those 4 pillars, we have a number of initiatives and programs and projects. We plan to develop our space robotics capabilities throughout the Mars 2117. Also, we are working on the in-situ resource utilization, and our catalyst project here is the CO2 conversion into glucose and polymer and other sort of products that could be used on the surface of Mars. Also, under the research and development, we are participating for the first time in an analog mission, the Sirius mission next year with our colleagues in IBMB in Moscow as part of the international group that will be participating in an 8-month isolation and confinement. Analog is an important mission for us because throughout the analog program, we are introducing our human research program, which is a new program that will be introduced for the first time, focusing on all aspects that allowing humans to sustain their long journey to Mars. Also, we have many other projects under the education. We had our first parabolic flight 2 years ago, which we included students at different levels, as well as our partners from other space agencies in conducting science and parabolic missions. All those programs and all those projects, we are planning to have them in a single platform. That is the Mars Science City, a dedicated city for all the development of technologies and science that will allow us in the future to send human to Mars. This is going to be our platform for international collaboration, the platform where we're going to have our space robotics capabilities, state-of-art analog facilities, as well as ISRU research labs that could be used along with our international partners in order to develop all aspects of the science technologies and answer as well the tough questions about the future human space flight and future deep space exploration. So this is a quick overview about the 2 missions that we have in 2 programs, the Immerse Mars mission and the Mars 2117. And I'll be more than happy to answer questions as well.
Oh, that was terrific. Thank you, Adnan. We'll go next to Ms. Kelly Geelen from the European Space Agency.
Okay, hello everybody. I've provided some slides as well, so if we could get my slides running.
Hi, folks.
While the slides are being prepared, I can in the meanwhile talk already about overall the ESA exploration program. For exploration, actually at ESA we have sort of the 3 pillars. So one is the Earth with the International Space Station, and then we have the same long-term goal of humans on Mars, and we use the Moon as a stepping stone towards that. So you'll see that we have a Moon program, or that we follow that together with NASA. And then for the Martian program, we have a combination of the ExoMars mission in collaboration with Roscosmos, Russia, and the Mars sample return Mars sample return mission in cooperation with NASA. So if I talk about the missions that are currently already ongoing, so actually we still have Mars Express in orbit already for 17 years doing excellent science, and then currently doing a lot of fantastic new science, as well as the Trace Gas Orbiter, which is sort of the first element of ExoMars. The next part of ExoMars will be launched in 2 years' time, in 2022, which would be the ExoMars Rover. Okay, if you just go through the next slide, I'll just go through them. Next one, please. So this was showing you the sort of the 3 targets that we're looking for exploration. Then if you go to the next one. So yeah, here you see a bit of an overview of at least the missions that are going to Mars, which is of course today's discussion's focus. As I said, the Trace Gas Orbiter on the top left, looking for methane in gases and mapping the subsurface ice, will be there for the coming years. Actually, also worthwhile noting that this Trace Gas Orbiter is doing a lot of data relay also already for the Curiosity rover currently on the surface of Mars. And then, okay, I'll talk a little bit more in a minute about the ExoMars rover, which we will agree to launch. And then after the ExoMars program, also within this decade, we'll have all the European elements as well for the Mars Sample Return Campaign, which would be the Earth Return Orbiter, the Sample Fetch Rover, as well as a robotic arm that will take the samples from the Sample Fetch Rover or the Perseverance rover and to put them on top of the rocket that will launch the samples back into Mars orbit. So next slide, please. This gives you a little bit of a picture of what the next ExoMars mission from in 2022 will look like. This is the Roseland Franklin rover. To me, at least, is really the next big step in exploration in situ. The big difference with this rover is that it has a drill, so we can go down to a depth of about 2 meters. This is very important because there the elements and the components will not be altered by galactic cosmic rays or radiation. So we think that's where the best science is to be done. And also very unique to this mission is the type of instrumentation that it has on board. It can do sort of the mineralogy and organics measurements and correlate the different aspects with 4 different instruments in its lab. And in order to select where it will take the samples, there's a ground penetrating radar. And of course, we use also the PanCam, so a vision system, to make sure that also when we go and look at certain samples in situ, that we'll look at the right places and the most interesting parts. So this mission will land with a lander, which is done in collaboration with Roscosmos in Russia. And on that surface platform that will land this rover, there's also a surface science package that will last for about 1 year on the Martian surface. So the next slide. So I think Laurie already gave a good overview of what the Mars Sample Return campaign looks like. I know if it's new, then it's quite a complicated system of different missions that all have to work together. But if we look into the more of the details, I think it's really well designed. It's very robust, that if something goes not fully according to plan with one of the elements, that another one has enough flexibility to be able to deal with that. I will not explain exactly how the campaign works now, but if there's more questions, I have some backup slides that we can go through later in the discussion. So I'll just focus on the actual the ESA element. So on the next slide, you'll see an image of the Sample Fetch rover. Unlike the rovers, the latest rovers, Perseverance and Curiosity, and as well the Roseland Franklin rover, this is a much smaller rover. There's no radio active sources on board. And it's really designed for agility, and to get there, it needs to go get to the sample depot, to go and catch them and bring them back to the surface element, and to launch it into orbit around Mars. And it's a bit of a race against the clock to make sure that we get there with plenty of time before the dust storm season might kick in. So then of course, this will bring the samples. Then there's a sample transfer arm on the lander that will take the samples from this rack you see at the front. At the same time, the Perseverance rover, which has a radioisotopic power source on board, might still be alive, can also drive back and deliver some other samples back to the surface platform. And this robotic arm will take them all and put them in the Mars Ascent vehicle. The Mars Ascent vehicle will launch and put these samples, which are in some sort of a football-sized canister, into an orbit around Mars. And then the next challenge, of course, is to go and grab that football and bring it back to Earth. So that's the task of the Earth Return Orbiter. On the next slide, you'll see a bit of an image of what this Earth Return Orbiter looks like. We call it the interplanetary cargo ship, with a very precious cargo. Different than most orbiters around Mars is that it has huge solar arrays because it's using electric propulsion. On the next slide, you see a little bit of a breakdown of what this Earth Return Orbiter looks like. So in order to be able to do a mission that goes to Mars and comes back and do it efficiently within current launcher capability, we have to make a very modular spacecraft, and we have to try and jettison anything that we don't need anymore or any longer. So you'll see that we go there actually with using electric propulsion. We have 4 gridded iron engines, and then we use a chemical propulsion stage to do an orbit insertion burn, which is the element you see on the left. This one we are about to sign the contract with Thales Alenia in Torino to build this element, while the main spacecraft will be built by Airbus in France, in Toulouse. For that, we are also finalizing the contract, although all the activities are running, and it's really going ahead. As in, we are currently procuring all the equipments like the onboard computer, and actually really at equipment level already trying to buy it from the different suppliers to be able to put it all together, ready for launch in 2026. And then, as Laurie already mentioned, we have also a big element provided by NASA, led by the Goddard Space Flight Center, which is sitting on the top of us, which is a capture mechanism to capture the orbiting sample that we've detected with a rendezvous system that ESA is designing. And then that sample will be biosealed and put into the Earth entry vehicle, which will be landing in the United States, where the samples can then be captured and investigated on the labs on Earth. So then on the next slide, I'll just want to put a link between the Mars sample return towards humans on Mars. I think it's a very important step, and not just Mars sample return, but also the ExoMars mission and what the Perseverance rover will find, because we will be able to determine what the environmental hazards are, not just for the humans that will have to operate onto Mars, but also if we find anything that we think might be dangerous inside the samples, then we know that. It's important that we know that before we also be able to return humans back to Earth, but also to look at preparing for building infrastructures for humans on Mars. We want to know if the soil will be good to grow potatoes. Then it's better that we have some soil first on Earth in labs that we can really investigate with the most modern technology, and to see that everything is ready for humans at Mars, and also for in situ resource utilization, which we will for sure need for sustained human presence on Mars. So that's a bit in a nutshell the different missions that Europe is looking in the next decade for. I'm happy also, of course, to take any questions at the end.
Thank you, Kelly. And our final speaker before we go to questions is Dr. Masaki Fujimoto. And I will turn it over to Masaki for telling us about Japan's Mars missions, upcoming Mars missions, and plans for the future.
Okay. My mic has been muted, so maybe I have to start all over again. But so this MMX is JAXA's Phobos sample return mission, and this is the mission I'll be talking about mainly today. So if you go to the next slide, you learn that MMX has a flavor of an asteroid mission. What do I mean by this? Phobos is one of the moons of Mars. It's a small body, and science-wise, it has a common theme as our asteroid sample return mission. The next slide shows our recent activity of Hayabusa 2. Hayabusa 2 is a JAXA's asteroid sample return mission. It has visited, its target body is Ryugu, one of the primordial asteroid, and Hayabusa 2 has completed 2 touchdowns and samplings, and it's on way back to Earth for landing in Umer, Australia on December 6th. And these 3 images shows the sequence of our touch and go sampling that was performed in July this year. And then the next slide. So why do we have Hayabusa and MMX? Well, 2 missions are members of our minor body exploration program. And ISA's small body exploration program is targeting at the theme of water delivery in the early solar system. Small bodies born in the outer part of the solar system must have brought water and volatiles to make our planet habitable. And it's such a big science topic that we think it deserves multiple sample return missions like Hayabusa 2 and MMX. And if you go to the next slide, it shows the mission profile of MMX. The launch will be in 2024. And after 1 year of cruise, we will be getting into the Martian system. And we're going to spend 3 years in the Martian system, including proximity phase around Phobos, including landing on Phobos. So the plan is to land on Phobos, stay there for a few hours, and do the sampling. And then it's going to take another 1 year to come back to Earth. And in 2029, we will be getting the samples back from Phobos. Next slide. I said it's a sample return mission. So how do we do the sampling? Unlike Hayabusa, we will be landing on the surface for like a few hours. And then we'll have a core sampling system. We have which on the tip of the robotic arm. So within the reach of the robotic arm, we will look for the best sampling site and get the core sample. That's one way of getting a sample. And because we're so seriously determined to get some samples, at least, we're going to have another sampler, which is a pneumatic sampler to be supported by NASA. So our coring sampler will be getting samples from subsurface, while pneumatic sampler will be getting samples from the surface. And there are different scientific themes that thinks that's best for subsurface sample as well as for surface sample. So I think our strategy of having two sampling systems is really, really nice to enhance the science we're thinking of. And the next slide. We will also deploy a rover on the surface of Phobos, and the rover will be provided by CNES and DLR, France and Germany. So MMX is really a full-scale international collaboration mission as well. The next slide is the picture of Phobos. So this is a Phobos sample return mission. We're trying to learn about the water delivery process in the early time of the solar system by understanding the nature of Phobos itself. But at the same time, if you go to the next slide, on the surface of Phobos, there might be samples from ancient Mars as well. Next slide, please. So what I mean by this is that throughout the history of Mars, there must have been an impact event on the surface, and the debris created by the impact event must have been ejected out of the surface, and some of them could have been showering the surface of Phobos. So if you get some samples back from the surface of Phobos, we might be getting at the same time some Mars samples as well. So this is my last slide. MMX is the first round trip to Mars. So it's the one of the most first step towards future human Mars exploration. And it's going to land and it's going to perform landing and sampling on the surface of Phobos and makes a detailed study of the moon of Mars, which may be an important element for future human exploration as well. So there are two elements that MMX has related to future human exploration. One is the first round trip to Martian system, and the other is the detailed study of the body, Phobos. So MMX also has a flavor of Mars exploration in addition to Asteroid mission. Yes, this is all I have to say. Thank you very much.
Thank you, everybody, for your excellent overview of your respective agencies and countries' current Mars missions and plans. We have a few questions from the audience, as well as a couple of things I'm curious about. I'm going to open with sort of a broad question is, what might surprise you about the missions that you have on the way or that you have developing in development for Mars? Is anybody, what would be the most exciting or surprising thing your current mission plans might reveal. It's open to the panel.
So if you may allow me to start. So for us as ExploreMars mission, as you know, it's our first mission, our first deep space mission. So everything is new for us. Everything is exciting. Coming from the launch of the mission all the way to operate the mission with a totally different concept of operation. We have great experience when it comes to the Earth observation mission, how to command and control a satellite orbiting Earth. But in terms of operating a mission to Mars and navigating all the way to Mars and hopefully doing the Mars orbit insertion and then doing all those scientific, we have all those scientific questions that I'd like to answer. Everything is exciting, and we really want to introduce a knowledge that is new, that the entire scientific community will benefit from. When you have truly a mission that will provide this global weather mapping, will provide this global seasonal day to night coverage of the Martian atmosphere. This unique knowledge and science, this is what we want to bring it here and share it with the international community. And we're very excited about that.
Lori, I see you smiling.
Sure.
What surprises or excitement do you anticipate?
Oh, gosh, Mars is great at delivering surprises. Every time we've gone, anyone who's gone, we find something new. And so I'm sure that there will be surprises that await us. As I think I mentioned, for the Mars 2020 and Perseverance mission in particular, I think this is, we've chosen a really exciting location that has potential to provide all kinds of surprises, not just in the search for potential biosignatures in life, which of course is one of the key things we're looking for, but even just bringing back samples that can help us understand the age of the Martian surface, to try and get some age constraints on Jezero crater, to help us understand how to actually calibrate ourselves in the Martian timeline. So I think there's all kinds of incredible surprises that are going to be awaiting us.
Anybody else have excitement or surprises?
Yes, I think on the European side, of course, we had a big surprise already with the trace gas orbiter. We expected we built a mission to look for trace gases and methane, and we got there with very sensitive instrumentation, and we didn't find any methane. On the other hand, on the Curiosity rover, we can see some traces of methane. So of course, there's a lot of mysteries to be resolved. And I think also with all this fleet of missions that are going there in the next decade, I think it will be extra exciting, because as we've learned that each mission answers some questions, but also raises new questions. So that keeps sort of the hunger for knowing more and the exploration nature and human beings going to keep doing and going further and to explore and learn the next new thing.
I think it's also important, the MMX mission, which is going to, I think, revolutionize our understanding of Phobos and that system. I'm really excited about that mission, and also in comparison to the other sample returns, both from asteroids and from Mars. I don't know if Masaki wants to add, but I think it's a really exciting.
Yeah, thank you. So this is less scientific, but we had enough surprises during our HABS 2 mission. And what's surprising about surprises is that general public people seems to like surprises. They really get excited whenever we have surprises. Like, when you visit a small body, you don't know well enough. You don't know well enough ahead of time to land on the surface of the body. But still, you have the mission. So you get there, you collect the information, and then you have to do it. You have to make your decision, and you have to perform it. And we should expect surprises for MMX as well, which is technologically unwelcome. But if you want to get involved people like surprises. So maybe we have to live with this. So professionally, I should say I don't welcome surprises, but I think it's the best channel to involve people and get people interested, be interested in space activity.
It reminds me, I just read the other day, somebody said, happiness is not the absence of problems, it's having good problems to solve.
True, yeah.
And I feel like the entire space community is all about solving the good problems and the hard problems. So one of the questions which you can surely have anticipated from the audience is, how do we feel, we as a panel, how do you feel about private efforts, and how does that fit into and each of you represents an agency and or a space center. So how do private efforts fit into this? Overall Mars exploration, whether it's robotic or human.
I'm happy to jump. I'm happy to jump in.
Yeah,
yeah, I saw that in the question there specifically.
Efforts,
yeah. I think from the NASA perspective, we absolutely welcome the commercial partners from around the world. I think the exploration of Mars is something that's done for humanity, and we welcome anyone that wants to be there. And I think we'll be able to leverage more capability, and that will help actually propel science even farther, and get us even closer to the goal of human exploration. So I know that from the NASA side, we're talking about both partnerships and collaborations with commercial efforts, but also the individual commercial efforts on their own. I think will all help benefit all of us in the future.
Yeah, I'd like to echo what Laurie was saying, and also I think it will start lowering the cost and the access of humans on the plans for SpaceX or of human presence on the surface. But also in the longer run, if there's a more private sector there, then they will also be able to build infrastructure like for communications and elements like that, which are also crucial, of course, for the types of missions that maybe the agencies will be focusing on more.
Definitely, when it comes to the private sector, allow me to add that you have huge knowledge gaps identified by the global exploration roadmaps, and all those challenges. Definitely, you need the private sector to work along with the government agency in solving those problems. But also, I would like to add also another important player, which is the academic sector. The example that we have here with the Mars mission, partnering with 3 major universities on developing the whole mission, from the concept to the mission itself to the operation. I think the academia and the academic institution, research institutions will play a bigger role in future deep space exploration and exploration of Mars.
Well, because we have been through this process recently, when I think about commercialization of Mars exploration, I always think about planetary protection. It was a heavy process for us, and then with more commercial participation, I think the discussion about planetary protection will change. And what is the best shape of the planetary protection discussion? I have no idea, but it will certainly be modified in the future. So that's what I predict.
And there's a panel on that later this week as well, with Lisa Pratt and Alan Stern and some of the other experts on the topic. And it is an interesting, I was noting as I was looking at all of your slides and listening to your talks, that while from a distance, from a public perspective, these are Emirati or Japanese or US or European missions, or the Indian mission, which is still at Mars, or from other countries and agencies, every single one is fully international already within each mission. And it's something that perhaps the public hasn't really had revealed to them, is that international collaboration has been happening on missions at a micro scale, mission by mission scale, for a very long time. And it's enabling sort of this bigger picture Mars sample return campaign, and then ultimately sending humans to Mars as a global community. And one of the things I'd like to ask about is, particularly because primarily all of these are robotic missions, what do you see looking forward, the role of humans and robots? There's the robotic explorers are less expensive, and there's the human explorers could solve all the robots' problems in minutes kind of camps that we see in the discussion, in the public discourse about this. But perhaps it's a teamwork effort. How do you see the roles of humans and robots going forward when we go to Mars? Let's start with Kelly.
Well, I think, well, it's something that comes, of course, the discussions keep coming back, and definitely it needs to be complementary. I mean, the things that humans can do, but okay, we can have only limited humans there, and we can do so much more if they are supported by rovers. And I'd be thinking of teleoperations. You could have one person operating multiple different elements that can go out in the field. Of course, you can think of, as Laurie mentioned, they're sending the first helicopter. So actually, by robots, you can also access environments that would not be accessible to humans. And I think an argument also that I recently heard, which I think is very important, is that if we send back data from a robot from Mars, yes, it's nice. We can see graphics and we can see pictures, very nice pictures, but it's very different than hearing a story with respect to the inspirational value. It's very different than a human being who is there and I will be talking to you from a different planet. So I think we should not underestimate the aspect of the human presence on a different, on Mars or a different planet, and them coming back with the stories of being there, which is something that you can never do with a robot mission.
Laurie?
Sure. I think Kelly has said it very well and covered pretty much all the bases there. And I absolutely agree that there's tremendous value in thinking about a human exploration that's done in concert with robotic exploration. Whenever we send humans to the surface of Mars, there are going to be some limitations on their mobility and accessibility to the surface. And by having whether robotic rovers or the aerial support that allows you to do some detailed reconnaissance and do the sortie planning, or actually having robotic rovers that can go out and do some of the work for you and extend your capability beyond the places you can access quickly. I think there's going to be an incredible, synergy between both those two approaches.
Masaki?
Yeah, so definitely there's going to be a synergy between robotic activity and human activity. So, and then it doesn't have to be only on Mars surface that we will have this kind of synergy. So, like when I talk to younger students, I always try to say that you don't have to wait until we land on Mars. You can start today. You can think about synergy between robotic activity and human activity, even on Earth, even on your everyday. So yeah, that's the way I try to persuade our younger students that your today can have linkage to the future human exploration of Mars. That's my narrative to my younger students.
It's great. Adnan.
So as you know, for the past decades that we had the robots visiting other planets, and whether they are orbiters or landers or rovers, it's time now that the human also to go back and participate, especially when you have new discoveries on another planet, and you want to respond to those new conditions or new discoveries. You need to have human there for fast decision making and taking actions. And those are the things that human will add and will definitely support future explorations. So yeah, I echo what mentioned earlier, and I just like to add this point, which is basically human bringing the decision making to the process.
Okay, someone has a question specifically for you, Adnan, which is what is the next UAE mission?
Sure. So when it comes to the UAE National Space Program, it's a sustainable program. When we started at the beginning with the Earth observation program, we started with 1 satellite. Now we have more than 4 satellites in orbit, and it's a sustainable program. We're working on developing our Earth observation program. When it comes also to Mars 2117 I mentioned earlier, it is a sustainable program. It's a generational program, which we're going to have continuous programs and projects and missions. When it comes to the Emirates Mars exploration, currently we are focused on the mission itself to successfully reach our orbit on Mars and doing our science there. However, this is not our KPI for a successful mission. It's not mainly about sending that mission to Mars, and if we fail and that's it, then we stop the program. This is just the beginning for us. We are definitely thinking now about the follow-on mission. We are doing our studies, and soon, within maybe months or maybe earlier, we will announce about our new mission.
Great, thank you. So I have one other audience question that you guys might have seen. How do you feel about this fleet, this global fleet? Someone called it an armada of Mars missions from around the world on their way. I mean, China has also got a rover on the way to Mars. So it really is an enormous number of global missions. How do you feel about that collaboration and sort of the big picture of what's happening at Mars? I will sort of seed that with my own opinion, which is, returning a sample from Mars or sending a person to Mars is by definition a global, not a national thing. The entire world will be changed by either of those, could be changed by either of those, certainly by sending humans and potentially by getting samples back. So we have about 4 minutes. I'd love some closing remarks and your thoughts on the international collaboration and independent missions.
If you allow me to start, sorry, go ahead, Laura.
So go ahead, Adnan.
Okay, sorry. So if you allow me to start, we're very proud and honored to be part of this international fleet going to Mars for the first time. And I think each mission is providing something unique to humanity. And we are very excited about this mission, about the international collaboration as well in our mission. Through the Emirates Mars mission, work with the university in the States, we're working with the different partners in Europe and working with the whole world on the developing different aspects of the mission and working the science and all of that. It is great to be part of the international community working towards a single goal, which is the Mars exploration.
I was really just going to add that, there's a lot of great science to be done at Mars. And what we've shown over the last few decades is that the more focused exploration that we have in that location helps us to really, really dig down into and really understand the planet and its formation, its evolution, and how it's become the way it is today, and what those implications are for planetary formation in general. And so there's so much science to be done, and by bringing together the global community to answer and address different parts of those questions, again, I think MMX is playing a fantastic part in that with the, looking at the moon system, the Mars moon system, in addition to the Mars surface. That'll be a fantastic addition to our complement of exploratory missions, and then all of those that are at in orbit and on the surface at Mars keep adding to our kind of catalog of knowledge and increasing that knowledge base. So I'm incredibly excited about the number of nations that are engaged.
Masaki?
Yeah, like in my position, I often have an uncomfortable chance to talk to the president of my agency or something, and then when I talk about Mars, I always tell him about the diversity. There are so many places we should visit and study, and then he looked annoyed. Or do you mean that you have to fly, so many missions by JAXA? So international collaboration helps, and yeah, when it comes to Mars, it's nobody claims that it's not, everybody understands there's a diverse science you can perform, and it's linked to the big science question. So yeah, I'm really happy that many nations are flying their mission to Mars, and Mars has that diversity that welcome so many challenges by these many missions. Yeah.
All right, Kelly, you have the last word.
Now, to me, it just summarizes. It's just really exciting. We cannot do anything alone. We need to all work together. I have seen such a great spirit in, for example, Mars sample return. Everybody working towards the same goal. We're really trying to everybody do their bit to also make the elements of the other partners easier, and really a collaborative spirit. And it's just a great opportunity with so many nations now going all to Mars, that we can just achieve much more than we've ever done before, which Mars sample return, for example, will be the next big step, I think. So.
Well, thank you, everyone. I have truly enjoyed our conversation, and I am looking forward to seeing everyone arrive at Mars and all the samples and other data coming back.